All right, let's try some warm-ups. So, on the warm-ups, they can be kind of challenging. The first one, number 1, what you need to do first in order to get rid of the square is to take the square root of both sides. After you take the square root of both sides, the square and the square root cancel. So you're going to be left with m is equal to, and remember, anytime we take the square root in an equation, we have to write plus or minus 1. On number 2, sometimes it helps when you have an equation to draw your line, so that way we know that we have a left side and a right side. And what we're going to do is we are going to begin by adding or subtracting. So I'm going to add 75. I get 3x squared equals 75. Next, what we want to do is we want to multiply or divide, so we're going to divide both sides by 3. When I divide by 3, this gives us x squared equals 25. Now it's just like that first problem where we have to get rid of the squared by taking the square root of both sides. So x equals, don't forget your plus or minus, 5. So x equals plus or minus 5. Number 3. Again, helps if you draw your line so that way you know you have a left side and a right side. First thing we're going to do is we're going to add or subtract. Add 12 to both sides. This gives me 5x squared is equal to 20. I'm going to multiply or divide. So I'm going to divide by 5. I get x squared equals 4. Take the square root of both sides. And I get x equals plus or minus 2. Good job. All right, now on to the exploration. So here's what we got. Working with a partner and answer the following questions. Use your calculator to evaluate the following expressions. So what we want to do is we want to make sure and have our calculator handy. So if we do our calculator, we want to take the square root of 50. So 50, and the square root of that gives me about 7.07 if I round to the nearest hundredth. So this will be 7.07. Let's do the next one. So I'm going to do it in parts. I'm going to do first the square root of 5, which is about 2.24. And then I'm going to multiply by the square root of 10, which is about 3.16. If I combine these, I can take 2.24 times 3.16, which is about 7.07 or 7.08. It would be about 7.07 if I had not rounded these answers. So it could be 7.784. We'll just say that right there. All right, let's check out the next one. Square root of 100. We should know already that square root of 100 is 10. If I do the next one, we're going to do the square root of 10. So the square root of 10 is going to be 10. I'm going to take the square root of 10, which is about 3.16. And if I take this again, 3.16, and I multiply these two values, I get about 9.9856. Now, what do you notice about these two numbers? So when we look at these two numbers, what do you notice about these two numbers? Well, if you notice, they are pretty close to each other. They're almost identical. Now, if I hadn't rounded, these would have been identical to one another. So the only reason why these were different is because I rounded these instead of taking the exact number, which was tough because they're non-repeating, non-terminal numbers. So if I had not rounded these would actually be identical to one another. So what do you notice? I notice they are the same. All right, on to the next. So, to the notes. The first thing that we're going to learn about is called the product property of radicals. So the product property of radicals. The product property of radicals says that if I have the square root of a times b, I can actually break it up into two parts, and I can say the square root of a times the square root of b. We use this property to simplify radical expressions. Now remember, an expression does not have an equal sign. So an expression does not, and an equation does have an equal sign. So if you notice, in example number 1, we want to simplify the expression. We're going to simplify the square root of 12. What we are looking for is we are looking to see if there's a perfect square that multiplies to give us 12. Well, I know my perfect squares, which include 1, 4, 9, 16, 25, 36, 49, and they keep on going. So you'll want to know these perfect squares. So we want to see what perfect squares can be divided into 12. Well, I know 4 is. I know 4 times 3 is 12. So I'm going to say the square root of 4 times the square root of 3. Now if I do this, I know the square root of 4 is 2. So I'm going to say, instead of saying square root of 4, I'm going to say 2. And square root of 3, we can't simplify. There's no perfect squares that will go into it. So this is the simplified form of this expression. Let's look at example 2, square root of 25. We're looking for a perfect square that goes into 25. So if you need to, you can always start off and say, all right, does 49 go into 25 or 75? No. 36? No. Does 25 go into 75? Yes, it does. So the square root of 25 times the square root of 3. Now we know the square root of 25 is 5. And the square root of 3 can't be simplified, so this is my final answer. Let's try number 3. So if I do this one, square root of 48. It's a little bit tougher. If you need to, don't be afraid to use your calculator. So in your calculator, we can say 48. 48 divided by, we can start off small, we can start off large. Let's do 48 divided by 4. If I do 48 divided by 4, I get 12. You know, 4 is a perfect square. So the square root of 4, we know, is 2. Are there any other perfect squares that go into 12? Well, yeah, 4 goes into it again, so I can say the square root of 4 times the square root of 3. I know that square root of 4 is going to be 2. And the square root of 3. So I will have 4 square root of 3. Now we could have done this problem the same way if we would have chosen a bigger number. So if I would have said that the square root of 16 and the square root of 3 Then I could have done it in a lot less steps, but you would have to notice that 16 goes into 48, which is probably not as noticeable as 4. So the square root of 16 gives you 4. Square root of 3 is 3. It's a whole lot easier, but a little bit tougher to recognize that 16 goes into 48 instead of 4. All right, let's have you guys try some work on your own. So simplify the expression. Start with number 1. To do this, we want to see which number goes into it. So the easiest probably way to do it is to say 16 and 2. I know that the square root of 16 is 4, and the square root of 2. 2 can't be simplified because there are not any perfect squares that go into 2, so this is my final answer. All right, go ahead and try number 2. All right, number 2, I have 132, so it's a big number, so I'm going to pull out my calculator. I'm going to start small. I'm going to say 132. I'm going to divide by my first perfect square, which I can use. I can't really use 1 because I know everything is divisible by 1, so I'm going to do divided by 4. And I get 33. So I know that 4 and the square root of 33. Now I know the square root of 4 is 2. And the square root of 33 doesn't really have any prime numbers to see if it goes into it. So this is my final answer. Number 3, go ahead and try it. So if you want to, you can try and work some numbers out. So if I do 63 and we do divided by 4, that doesn't work out. We get a decimal. We need a whole number. We don't want to use 15.75. We're only looking for whole numbers. So let's do another one. Let's do 63 divided by, my next perfect square is 9. Oops. And I get 7. So I know that the square root of 9 and the square root of 7 multiplies to give you 63. We know the square root of 9 is 3. We can't simplify the square root of 7, so we get 3 root 7. All right, let's do a little bit more. We also have another property, which we like to call the quotient property of radicals. So the quotient property of radicals says that if I have the square root of a fraction, a over b, I can actually break it up. So it's the square root of a over the square root of b. We use this property to simplify expressions, radical expressions. So let's go ahead and take a look at some problems and how to use the quotient property of radicals. So what we're going to do on the first one, number 1, is we are going to write this out using top and the bottom, numerator and the denominator. So I'm going to break it up into 2 parts. I'm going to say the square root of 4. I'm going to break it up so it's the square root of 9. Now if I do the square root of 4 over square root of 9, I know the square root of 4 is going to be 2. And I know the square root of 9 is 3. So my answer is 2 over 3. Number 2, I'm going to do the same thing. I'm going to break it up and see what we have. So if I do this, I'm going to break it up on the top. So I'm going to say the square root of 32. And I'm going to say the square root of 50. Now if you look, we can't simplify anything yet, so we have to simplify 32 and 15, or 50. So what we need to do is we need to figure out what perfect square goes in both 32 and 50. If you need to, you can always use a calculator, but I know that 4 goes into 32. I also know 16 goes into 32. So I can say 16 and 2. I'm going to simplify the top. And a perfect square that goes into 50 is going to be 25. So I have the square root of 25 and the square root of 2. Now, do you notice anything that's on the top and the bottom? Well, yeah, they both have a square root of 2, so whatever's on the top can always cancel with what's on the bottom. And I can simplify this, and I can say the square root of 16 is 4, and the square root of 25 is 5. Let's try number 3. Again, what I'm going to do is I'm going to break this up into 2 parts. So I have 5, I have the square root of 1, and I have the square root of 25. Now, if we need to, you can always write 5 as 5 over 1. Now I'm going to simplify this by first simplifying my perfect squares. I know the square root of 1 is 1. I know the square root of 25 is 5. If I combine these, this will give me 5 over 5, which is equal to 1. Try not to introduce equal signs because a lot of people get confused and then they try and solve it. So I like to use arrows instead of saying an equal sign. So here we go. Why don't you practice number 1. To do this, we are going to break up the top and the bottom. So to do this, I'm going to have the square root of 49, and I'm going to have the square root of 36. To do the square root of 49 and the square root of 36, I want to just simplify. We know the square root of 49 is 7. We know the square root of 36 is 6, so I have 7 over 6. Let's do number 2. Try it out on your own. So the first thing that we're going to do is we're going to break it up so that we have the square root of 1 and the square root of 9. Of course, one thing we can do is always write 3 is 3 over 1. So this way, I now know that 3, I know the square root of 1 is 1, so 3 times 1 is 3. I know the square root of 9 is 3. 1 times 3 is 3. Square root of 3 over 3 is equal to 1. All right, go ahead and give number 3 a whirl. So what we want to do on number 3 is we want to break this up into 2 parts. So I'm going to say the square root of 80 and the square root of 45. We're going to see if there's any perfect squares that will go into both 80 and 45. Well, if you need to, for 80, you can always use your calculator. You can say 80 divided by 4, which is 20. If you notice, 20 also has a perfect square in there, so I'm guessing that there's probably a bigger number that goes into it. So let's see if we can figure out a bigger number that goes into 80. So if I do 80, my next perfect square is going to be 9. If I divide by 9, that gives me that. I can't use that because it's not a whole number. I'm going to do 80 divided by 16. I get 5, so that'll work. So if I do this, I know that I can simplify 80 by saying it's the square root of 16 and the square root of 5. For 45, I know that the square root of 9 times 5 gives you 45, so this will be square root of 9 and the square root of 5. If you notice, we have something that's on the top and the bottom, which is a square root of 5. So let's cancel that out. We now have the square root of 16, which is 4, and the square root of 9, which is a 3. This is our final answer. All right, on to some more notes. So in our notes, when we get a radical symbol in our denominator, we need to rationalize the denominator. All right, that may seem like a lot of rationalizing and radicals and denominators. So let's make sense of what we just put down. So here's what we got. First thing that we're going to do on number 1 is we want to simplify the square root of 1 over 18. Now, if I simplify the square root of 1 over 18, I'm going to use the quotient property and break it up into 2 parts. I'm going to say the square root of 1, and I'm going to say the square root of 18. Now, if you notice, the square root of 1 we know is 1. I'm going to have the square root of 18. Now, in order for a fraction to be simplified, we cannot have a square root in the denominator. We cannot have this radical in the denominator. So what we need to do is we need to do an operation to get this radical out of the denominator. So what we're going to do is we're going to multiply the square root of 18 times the square root of 18. So if I do this, I know that 1 times the square root of 18 will be the square root of 18. And I know that square root of 18 times the square root of 18 will actually be just 18. Now, we're not done yet because square root of 18 can still be simplified. There's still a perfect square that goes into 18. So that perfect square is going to be 9. So I can say that this will be 9 times the square root of 2 over 18. You know the square root of 9 is 3, so this will be 3 root 2 over 18. And finally, 3 goes into 18 6 times. So 3 goes into 3 once. 3 goes into 18 6 times. So my final answer will be the root 2 over 6. All right, let's try another one. Number 2. First thing that we have to do is we want to use the quotient property so that we get the square root of 27 over the square root of 15. So if I do this, I have a square root of 27 over square root of 15. Well, this problem is a little bit challenging, so let's do something before we do this. All right, because if I try and multiply this by 15, I'm going to get a huge number. If you notice, one thing that we haven't been doing, but we could be doing, is we could use still the order of operations, which says, please excuse. Please stands for parentheses. So now parentheses, there aren't any in the problem, but if you notice, since it's inside of the square root sign, we're actually going to treat it as parentheses. So how can I simplify 27 over 15? Well, if we do this, I know that a number that goes into both 27 and 15 is 3. So 27 divided by 3 is 9. 15 divided by 3 is 5. Now I'm working with a lot smaller numbers, and I can break this up into the numerator and also the denominator. So now to do this, I need to get rid of the square root in the bottom, so I'm going to multiply the top and the bottom by the square root of 5. I'm going to have square root of 9 and the square root of 5. Well, we know the square root of 9 can be simplified. We know the square root of 9 is 3. We have the square root of 5. Anytime I have the square root of 5 times the square root of 5, that just gives me 5. And this is your answer. All right, number 3. What I want to do is I want to break it up into the numerator and the denominator. So I'm going to have the square root of 5 and the square root of 12. Once I have the square root of 5 and the square root of 12, I'm going to multiply top and the bottom by the square root of 12 and the square root of 12. Now if I do this, I can use the product property that says 5 times 12 will give me the square root of 60. Or if I want, I can say that I know there's a perfect square that goes into 12, so I can break 12 up. So I can say the square root of 5, and I can break up 12 because I know there's a perfect square that goes into it, which is 4, and the square root of 3. Bottom I have 12. Now I know the square root of 4 is 2, so I'm going to have that, and then the square root of 5, and the square root of 3. Finally, I'm going to combine my 5 and my 3 to give me the square root of 15. I can do that because they're both underneath radical signs. And then I get 12, and I can simplify 2 and 12 because I know 2 goes into 2 one time, and I know 2 goes into 12 6 times. So my final answer will be root 15 over 6. All right, time for you guys to try something. First, try number 1. To do number 1, first thing that we're going to do is we're going to write it out using the quotient property, square root of 3 and the square root of 5. I'm going to multiply the top and the bottom by the square root of 5 in order to get rid of the radical. When I do that, I now have square root of 3 times the square root of 5, though neither of them have a perfect square in them, so I can combine them. So this will be the square root of 15. And if I do this one, the square root of 5 times the square root of 5 will give me the square root of 25. We know the square root of 25 is 5, so I can say square root of 15 over 5. Now, a lot of people at this point say, hey, can we simplify this? Well, no, because 1 is underneath the square root sign, and this one is not. So we can't say 15 divided by 3, 15 divided by 5 is 3, because this one's in a radical sign and this one is not. So this is my final answer. All right, go ahead and try number 2. So if we do this, we're going to break it up. So the top is in its own radical sign, and the bottom is its own radical sign. I can simplify this because I know that the square root of 1 is 1, and the square root of 3 remains square root of 3. Now to do this, I'm going to multiply the top and the bottom by square root of 3. If I do this, I know that 1 times the square root of 3 will be the square root of 3. On the bottom, if I have square root of 3 times the square root of 3, this will give me the square root of 9, which can be simplified to give me 3. If I go ahead and try number 3. To do number 3, I'm going to break it up into 2 parts. I'm going to say the square root of 16 and the square root of 10. Now we should know that the square root of 16 can be simplified because it's a perfect square, and this will give you 4. The bottom is going to remain square root of 10. So if you notice, there's no perfect squares that go into square root of 10, so what I'm going to do is I'm going to multiply the top and the bottom by the square root of 10. And when I do that, I will now have 4 square root of 10. And the square root of 10 times the square root of 10 is 10. We can still simplify because 4 and 10, they're both outside of the radical sign. So I know that the number that goes into both of these is 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. All right. Review / more practice. Simplify the following expression. Go ahead and try it on your own. To do this, what we want to do is we know that square root of 63 can be written as square root of 63 over 1. If we do it, we can thus write the square root of 63 over 3. Now the square root of 63, we want to see if there's a perfect square that goes into 63. It's one of those weird numbers. Maybe you know it right off the bat, maybe you don't, but I'm going to try it out. 63 divided by 4 doesn't work out, so I have to have a whole number. I'm going to do 63 divided by my next perfect square, which is 9. 9 times 7. So I can break this up, and I can say the square root of 9 and the square root of 7 all over 3. Now we can simplify this because the square root of 9 is 3. And you notice there's a 3 on the top and the bottom, so those can cancel out, and I'm left with my answer of square root of 7. All right, go ahead and try number 2. All right, for number 2, we know our answer is going to be negative. We have that negative out front, so we have to remember to put that negative into our final answer. So that's going to be a negative. You can draw an arrow down and not have to worry about it until the end because we know there's going to be a negative when we do our final answer. Now what I'm going to do is I'm actually going to simplify using the quotient property. I'm going to break this down so it's a square root of 25 and the square root of 16. Now we know the square root of 25 is 5. The square root of 16 is 4. And we got that negative there, so I need to have negative 5 over 4. All right, number 3, give it a whirl. First thing we're going to do with number 4 is we are going to, right, negative 4 is negative 4 over 1. I'm going to break the square root of 1 and the square root of 10 up so that 1's in the numerator, 1's in the denominator. Now I know the square root of 1 is 1. 1 times negative 4 will give me negative 4. Now I need to get rid of that square root sign in the bottom, so I'm going to multiply the top and the bottom by the square root of 10. And on the top, I'll have negative 4 root 10 over 10. Now a number that goes in both 4 and 10 is 2, so this will be negative 2 root 10. 10 divided by 2 is 5, so this gives you your final answer.